This is the last property we'll talk about of rational functions. The directions say for the following exercises, find the slant asymptote of the function. So this book doesn't call it a slant asymptote, it calls it an oblique asymptote. So this here is an oblique asymptote, and that's what the book uses here. So we're going to talk about that now. So if we're going to find this slant or oblique asymptote here, I circled 30 and 33, so we're going to take that first function here, of 30, and we're going to find the slant asymptote. And I'm just going to write it out so you know which function we're using here. And what I said is we're actually just going to have to divide it. So 2x plus 1 on the outside, and on the inside of this is going to be 24x squared plus 6x. And I have to put a plus 0 here, just for the sake of filling every slot, x squared, x, and a number. Okay, so now I'm going to say, what do I multiply 2x by to get 24x squared? So that's the first thing. And again, I have two terms here, so I'm going to have to move over two terms here. So that number I'm going to put in is going to be 12x, and I'm going to put it right over the 6x since that's the second term. So then when I multiply this through here, that's going to be 24x squared, and then 12 times 1 is 12, so this is going to be plus 12x. And then what we do once we get that number is we subtract it, or expression I should say. So then those zero out, and I end up with negative 6x. Because I'm minusing a positive 12x. So that's going to be negative 6x. And I bring down the next thing, the plus 0. So now what am I going to multiply 2x by to get negative 6x? So I'm going to say minus 3. So that's going to be negative 6x minus 3. And I'm going to take that whole thing and subtract it. So those go away. And minus a negative 3 is really adding 3, so that's going to be a positive 3. So that's my remainder. But when we're talking about these oblique asymptotes, all we need here is the qx. The qx is the oblique asymptote. So once I do the long division, assuming I do it correctly, I would say my oblique asymptote, and I'll write that out. And I would say y equals 12x minus 9. So there's my answer for this one. And again, like I said, it's just long division. That's how these equate. All right, so anyways, now let's move on to the next one. That was number 30. Now let's do 33. And that doesn't change. So that simply means then we're going to take... and I'll just write this back out again. F of x equals 6x cubed. Let me fix that 3 again. Minus 5x over, and that's going to be 3x squared plus 4. And then we're just going to do the same thing. So I'm just going to take the bottom. Now it is missing an x term, so I'm going to say plus 0x. Actually, I don't have to, because they're both missing the term after them. I could get away with not putting the 0 in. If you're not sure about that, or that's confusing to you, you can actually put it in. So 6x cubed minus 5x. So what am I going to multiply 3x squared by to get 6x cubed? And I would say 2x. And again, I put it over the second term. So that's going to be 6x cubed, and that's this one here. And then now I got to times it by the 4. So that's going to be plus 8x. Now I take that whole thing and subtract it. And that's going to be negative 13x, because minus a positive is going to be a negative really, because I got a negative 5x here. So it's going to be negative 13x. And I'm done. So this tells me here, and the reason why I know I'm done is because this degree of the polynomial there is smaller than this degree here. So that tells me I'm done. So that oblique asymptote is going to be y equals 2x. Just remember that oblique asymptote is the qx. Now, one thing to notice here on top of everything we've done so far, just simply divide it, and that's going to be the oblique asymptote. But for each of these, notice the degree on top for the first one is 2. The degree on the bottom is 1. This difference is always, the degree on the top is going to be 1 larger than the bottom. And these are all that way. If you look at every one of these problems, they're all just a difference of 1 degree on the top. When I see that, I have an oblique asymptote. So that's just a quick indicator that tells me what I'm dealing with right away. Now the top has to be a larger degree than the bottom by 1. So there's our answers for this one. So in and of itself, just to find the oblique asymptote isn't too bad. It's just division.